Hi everyone, I'm Hugo Liu. I'm the CEO of Orchestra, the best-in-class data pipeline management platform. And in this video, I'm going to show you how data teams can run sophisticated anomaly detection without going for any additional tooling. So something we've seen consistently in data are vendors bringing out anomaly detection software. Now, historically, doing anomaly detection on your data has been kind of hard. And this is because it necessitates quite a big transfer of information. So here I'm going to show you just a very basic table, which is some sales over time. Now, in the past, right, if we wanted to identify anomalies in this data, we would probably have to export this data somewhere. You'd have to train a model on a subset of this data. You'd then have to forecast, that model for the testing set. And then you'd have to run that in production somewhere. And then with those predictions and the predictions of what are anomalies, ping them back over into somewhere to be stored. So quite a lot of extra stuff to do just in order to basically get an alert of what's gone wrong. Now, most data warehouses are now adding this functionality native. So you can obviously do this in Snowflake, but it's being added to other warehouses like BigQuery through Vertex, and obviously also Databricks. So in this video, I'm going to show you how you can do it in Snowflake. So as you can see here, we've got some data. It's actually tabular and is more complicated than just a single time series because it's also split out by store. So in this case, we don't just want to do anomaly detection on a linear series. We've actually got some kind of sub-series here as well. The rationale being what's an anomaly for London might not be an anomaly for another city in the UK. So if I take this out, I can show you what that looks like. So we can see this is essentially panel data. So what we're going to do is we're going to define a subset of this data to be our training set. I'm going to create a table called store sales edited, and it's just the underlying data, but before this date. So we're kind of going to imagine we're on the 17th of November, 2023. For the data after that, we're going to create that as the prediction set or the test set, if you like. And then we're going to go ahead and create this anomaly detection model in Snowflake. Now, it looks complicated, but it's really not, and I'll walk you through this function. So what we're doing is we're creating an anomaly detection model. This is essentially like a data science model, and under the hood, it's essentially seasonal autoregressive integrated moving average, so SARIMA. The first parameter you need to put in is the input data, and this is basically your training set. You can see here I've been a bit lazy and I've just put in the query, but you could also reference the table we just made. Because we're doing anomaly detection on a time series, we need a timestamp column. That's the date. For the thing we're trying to measure, so sometimes a dependent variable, in this case they call it target call name, that's sales. If you have panel data, so you're effectively trying to do anomaly detection on multiple series contained within the same data set, you need to add in the label column name, the series column name. And in this case, that's the store. For this example, you can ignore the label column name. So I'm going to go ahead and create that. But yeah, I said earlier that we're going to imagine we're on the 17th of November 23. Technically, you'd probably be, at least one day after this, right? So we can see actually the maximum date in this data set is the 19th, because obviously, you're not going to be able to do anomaly detection on stuff that's in the future. So after you've created your model, right, this model is basically trained on the training set. The next thing to do is to call this model on the test set. In this case, it's that table I made earlier, store sales predict. I'm we can see Snowflake is executing, so I might skip. No need. Awesome. So we've got 3 stores, 2 days, 6 observations, happy days. And Snowflake gives us some great stuff. So it gives us the forecast, the lower bound, and the upper bound. So if we take a look at this one, we can see the lower bound is 1053, the upper bound is 1197. So this is actually, it was actually at 1007, so way too low according to Snowflake, and it's therefore in a very, very small percentile, and it's therefore an anomaly. Now you might be thinking, okay, Hugo, that's great, but how am I going to run all of these queries in production? And you'd have a good point, because what you'd probably want to do is every day create a new sort of view, or at least update a select statement for the latest day's data, and maybe every day or every week, depending on how sensitive and moving your data is, retrain your model so it can take into account new data. You then obviously need to update this, so you need to run that. And then in terms of getting this data, we've got the anomalies, but where are they, right? This isn't stored in a table anywhere. And, you also don't have an alert on it. So fortunately, there are sort of data pipeline management systems like Orchestra that take a lot of this, all of this complexity away. So in this case, we actually have an anomaly detection task, which is essentially a parameterization of the process you just saw, where all you have to do is provide a SQL statement that determines where your training data is. Similar thing for the prediction. You throw in the parameters for your timestamp and target column name. And then because Orchestra has a scheduler, we take care of running this on a schedule. And that's one of the ways you can get something like this into production. Obviously, you could also do something like this using something like Snowflake tasks. Awesome. So in this video, we saw how you can leverage your existing cloud environment to run sophisticated anomaly detection. One of the biggest pains, of course, is actually having to run this in production. But tools like Orchestra, tools like Snowflake are able to help you abstract some of these pains away, and augment this very powerful capability with something essential like a scheduler. So I hope this was interesting, and if you take anything from it, it's definitely check to see if your warehouse or lakehouse provider offers some kind of anomaly detection before trying to write this yourself. If you've got any questions, feel free to reach out to me on LinkedIn.